Hello dears, we are studying strength of material and today's topic is strain. What is strain and what is type of strain? So today we will discuss about strain in detail. Strain is measure of deformation. It is the measure of deformation. When force apply on a body, then stress produce and due to stress the deformation on the body takes place. So this deformation is called strain. A strain is a measurable quantity, that is change in dimension per unit original dimension. It is a strain. A strain is equals to change in dimension per unit original dimension. It is denoted by epsilon. So epsilon is equals to change in dimension by original dimension. Here the ratio of dimensions are same. Therefore it will be unitless quantity. And strain is unitless quantity. It is no unit because same dimension cancel to each other. So it is unitless quantity. Now we will see types of a strain. So type of a strain is equals to corresponding the type of a stress. Type of a strain, it is corresponding to type of a stress. Because a strain produced due to a stress. So which type of a stress act on a body, that strain will be there. First, normal stress. So according to normal stress, the strain produces normal strain. Due to normal stress, the strain produces normal strain, and it is represented by epsilon n, not a del L, epsilon n. Next type of strain is according to stress, that is longitudinal stress. So according to longitudinal stress, the next type of strain is longitudinal strain. Longitudinal strain, and it is denoted by epsilon. Next type of strain is according to shear stress. So according to shear stress, the strain is shear strain. Shear strain, and it is denoted by phi or gamma. Now we will see detail about longitudinal strain. So longitudinal strain is change in length by original length. That is the deformation along the length is called longitudinal strain. Longitudinal strain epsilon is equals to change in length by original length. It is longitudinal strain. That is epsilon is equals to del L by L. Now next type of strain is shear strain. So what is shear strain? For this we draw a body. We draw a body and we understand about shear strain. We take a body, this one is body, and here if we apply the shear force, that is V. So if we apply shear force V, then the deformation will be shear in the body. So when we apply shear force V, then body also apply the one force, that is reaction force, and one end of the body is fixed. So deformation will be like that. This is deformation, and this deformation is equals to del L. Del L. This deformation will be del L. Now we take a name, that is A to A dash. Deformation will be A to A dash, and here B to B dash. Body, and it is the angle between the deformation, that is A to A dash and B to B dash. So angle between the deformation is phi. This is reaction force which is created by the body after applying the force. Therefore shear strain is equals to del L, and del L is equals to A dash, and it is equals to BB dash. That is shear strain. So how will calculate the shear strain? First we see the when apply shear force on body, then body try to tilt from A to A dash and B to B dash. When apply shear force in the body, then body try to tilt from, that is deformation is A to A dash, and one deformation is B to B dash, and the angle between the deformation is phi. Now we will take one triangle. So we take in triangle A dash D, A dash D. In that triangle, tan phi is equals to tan theta is equals to P by B. So according to this, tan phi is equals to A dash by AD, and AD is called length, that is L. It is the length. So A dash by AD, it is equals to A dash is equals to del L. So del L by L. Here phi is very small. The angle between that A dash, or we can say the angle between the deformation is very small. Here deformation is very small. Therefore tan phi is equals to phi is equals to del L by L. That is shear strain. Now lateral strain. What is lateral strain? So lateral strain, deformation in lateral dimension, that is lateral strain. In a simple way, the deformation in lateral dimension, it is equals to change in lateral dimension by original lateral dimension. It is called lateral strain. How will produce the lateral strain? Now we will see. So for lateral strain, we take a body. We take another body for lateral strain, and this body is 3D, 3 dimension. This one is body, and this body is 3 dimension. Therefore, this is the length for body L, and it is called, and the deformation along the length is called longitudinal strain. So it will be a longitudinal dimension, and this cross section, that is A into B, this cross section, that is A into B, that is, we can say, A by B. So the cross section A by B is called lateral dimension, and according to this body, the deformation along lateral dimension is called lateral strain. So we can say the deformation along cross section. Here, when apply the force, then deformation will be body. So when apply the force on both sides in longitudinal dimension, then the longitudinal strain will produce, and due to which the cross section area of the body will reduce, that is, lateral dimension is reduces. So we can write here, when deformation takes place in the body, then with the increasing in length L, the cross section area of body. So what is cross section area? It is lateral dimension. Cross section area is lateral dimension and is equals to A by B, that is A into B. So the cross section area of the body A into B will decrease. And its dimension, that is lateral dimension, will reduce. We take a body, this one is, and we apply the force. So this is the diameter of body, and this diameter is D. After deformation, this body will be like this. After deformation, when apply the force on a body, that is a pull force, you can apply all the force. So after deformation, the body will be like this. Here the deformation, this is the deformation on the body. So D will be D dash, because its diameter will reduce, and this is L, and L will be L dash, because its length will increase. So lateral dimension del D is equals to D minus D dash. It is the lateral dimension, and we can say lateral dimension del D is equals to epsilon D is equals to del D by D. So it is called lateral strain. ED is equals to del D by D. So these are the all about strain. Thanks for watching.